Hello everyone, I'm going to do something a little bit different today. Instead of solving a math problem as usual, I'm going to go and give my personal ratings of different number systems. Let's not dilly-dally around too much and get right into it. Starting with the positive naturals, let's go through some of the pros. Well, positive naturals allow us to do most basic everyday mathematics. We can count things, and yeah, that's most of everyday mathematics. We can make just about every important statement in number theory using just positive naturals, and they are a fundamental tool which help us to fall asleep at night. I'm talking about counting sheep. Let's look at some of the cons. Well, positive naturals are like a pre-beta version of a general number system that we've wanted for a long time. We spent a really long time using only positive naturals, even though it's so much better to have more than that. But I figured it's important to talk about the positive naturals because of their historical place. Number theory is only interesting to people who like number theory. This is an indisputable fact. Can't really argue with this. So all in all, I give positive naturals a final rating 6 out of 10. Okay, let's go on to the naturals. A pro. Well, this finally gives a sense of identity to addition. Before this, addition was walking around not really knowing who it was. The number 0 sounds really cool. I just like to say it, 0, 0. And the naturals allow us to finally write zero to hero storylines. You know, a lot of our superhero movies these days are all about 0 to hero. So that's nice. Cons. Well, the naturals over the positive naturals, it adds literally nothing to the previous number system. So, you know, what are we doing really? By introducing a 0, we break division in a lot of cases, and this has caused angst to young students all over the world. Final rating for the naturals, I give this one a 6 plus 0 out of 10. Let's talk about the integers. This is the full proper expansion we've always deserved. It allows 7-year-olds to do impossible things, like take 12 apples away from 7 apples. Before the invention of the integers, this just was not possible. Now it opens up so many possibilities. We have nearly twice as many numbers to play with in moving from the naturals to integers. I say nearly twice as many because 0 doesn't really have a corresponding pair like all the other integers do. But even by almost doubling the number of numbers to play with, we don't really add any additional memory requirements. It's pretty remarkable how this was possible. Let's talk about some cons. Okay, so there's an unfixed bug in the integers that has been around since it was first released. It doesn't look like it's ever going to get fixed, but allows 2 wrongs to make a right. This just seems like it shouldn't be the case for most of us, but I don't see it going away anytime soon. The integers also allowed for proper recording of financial debt, and nobody really knew the long-term consequences of this, but it eventually gave rise to the modern finance bro. Apologies to any finance bros who are watching this video. Final rating for the integers, I give this one a 9 minus 1 out of 10. Okay, moving on to rationals, pros. So we can finally play with non-trivial limits. In all the previous number systems, any limit we had, if it existed in a trivial sense. So we get to play around with something a little bit more interesting here. It opens the door to a broad class of functions which are sufficient for most applications. Just about every computation that's done in the real world is done with rational numbers. So for the most part, it seems like it's all we need. Rationals are also a fundamental backbone for rating systems, like the one I'm doing now. This video would not be possible without the rationals. Rating things out of 10, it wasn't possible with the integers, but here we go. Cons. Well, when the rationals came out, it gave us a sense of incompleteness in our number system, and there were just too many gaps to be filled with rationals alone. But we'll get to there in the future and see what can be done about that. Rationals have a reputation of being kind of uncool compared to younger brothers, but this is undeserved in my opinion. I think the rationals are pretty hip. I give a final rating for the rationals, 19/2 out of 10. Let's move on to the reals. Okay, pros for the reals. Trigonometry, exponentials, irrationals. This is an incomplete list. I could go on for a long time with all the things that real numbers introduce. Real numbers are pretty good for physics, I guess. Most computations in physics or most theoretical stuff in physics is done with real numbers. Yeah, let's move on to the cons. Well, trigonometry, exponentials, and irrationals. Maybe a little bit more complication than I really care to deal with. Real numbers are total overkill with the amount of content added. Going from rationals to reals is just an absolute explosion in the options available for what we can play with. It adds more numbers than we could ever count. Probably the real numbers introduce more problems and paradoxes than it was worth. And people have literally been murdered over disagreements about real numbers. So I've been told. Final rating for the real numbers from me is e to the negative pi out of 10. Okay, let's move on to the complex numbers. The pros. Well, keep in mind that in developing the complex numbers, we were handed the mess that is the real numbers. So given that we have to work with the real numbers, complex numbers are great. It's a much needed completion of R. For example, are there roots? Yes, n of them. Always, end of story. Complex numbers give rise to some of the most elegant mathematical theory. If you ever study complex analysis, you'll know what I'm talking about. It's just cool. Everything just works. Cons. Well, it introduces one of the worst naming conventions in all of mathematics. There is nothing more real about the real numbers than the imaginary numbers. We have people all over the world walking around thinking that imaginary numbers don't exist in some sense and they should be avoided. No. It's just a bad name. That's the only thing that's wrong with the complex numbers as far as I'm concerned. Final rating, I give this 6 plus 8i out of 10. A perfect rating as far as I'm concerned. And finally, let's talk about the quaternions. Pros. Well, really good demonstration of an example of a particular structure in any algebra class. You have a ring which allows for divisibility. It's non-commutative. Okay, cool. We have an example of that now. Great. I think these things are used in like computations related to computer graphics, maybe other stuff that has to do with rotations, something like that. I don't know. Let's go to the cons. So non-commutative numbers, like nobody wants this. No one asked for this, and yet we're given this. And seems to be like the main feature of the quaternions. I mean, who cares? Just call yourself a matrix. You don't have to be a number all the time. It's okay to be a matrix. Quaternions are basically like matrices. And has anyone actually used these for anything meaningful? I don't know. I certainly haven't. Final rating, the quaternions, I'd give this one IJK out of 10. That's it. Thanks for watching. Let me know what your comments are. Keep in mind, these are my personal ratings. Some of you may have different opinions on how you feel about these different sets of numbers. Thanks for watching.